need you to come over here right away. We've got a problem. We need to take care of it. So, can you get here as soon as you can?
Okay, I'm on it. Thank you.
Hello.
Hey, Jason, listen, I need you to get over here right away. We've got a problem. Need to see you right now, ASAP.
Yes, sir. I'm on my way.
Come in. Gentlemen, we have a problem. It seems like the pH of the water in western Oklahoma is a lot different than the pH of the water in eastern Oklahoma. I need to find out what the problem is. So your job, if you accept, is to find a sample of water from western Oklahoma, from eastern Oklahoma, and tell me the pH of that water.
Yes, sir. We'll do our very best.
I think there's a nearby pond over there that we can check the pH levels for. That could be a good place to start with this.
We should get some water samples from there first.
Okay, this would be a good place for the water. I think we can get a great sample here and not get bit by any sharks.
I have the sample.
Way to go, Nostradamus. Now it's time for us to go to the east side and get some more samples so we can test these for what pH levels they have. And then maybe we can find out why they're so different.
Should we walk or should we drive?
We should definitely walk. Someone's going to take us there.
I didn't think we were ever going to get here.
Oh my God. Well, all right. So we've got our sample from the west part of Oklahoma.
We do, and we have a test tube for the eastern Oklahoma.
Good.
This would be a good spot to take our sample.
I think this is just wonderful water to do it with.
And I have the sample.
Excellent. Jason, what are you doing? Where'd you go?
Lunch.
Well, now that we got two samples, what we need to do, we can go into our lab up here. We can get a third sample of the tap water, and then we can go with our business, find out for Stan what's going on with the pH.
I think that's a good idea.
Excellent. All right. Well, we need to get our final sample, our three samples. We've gotten one from the west, we got one from the east, and now we need to get it from the tap water.
We have the sample.
We have our three samples now. My question for you, do you have the pH meter?
I have the pH meter.
Now we're going to use the pH meter. Turn it on. You do the honors. And this is West Oklahoma. 7.2.
Eastern Oklahoma.
Western Oklahoma. Eastern Oklahoma. 7.0.
There is a difference in pH.
Quite a bit. And then finally, our tap water. Let's find out what that is. And we have 7.6.
7.6. I have a great idea. Let's graph the results so it'll make it easy for Stan to understand what's going on with this pH.
Gee, Stan will love that.
Thank you!
So graphing data is pretty easy. What we're going to do right now is we're going to take our numbers that we got from the pH of all three of our samples and make a bar graph. So here's what we're going to do. Come on in and take a look.
Alright, first off, we're going to make the outer parts of our graph, like so. What we need to do now is we need to give numbers. Now, our range really wasn't that big for our specific numbers with the pH of our water, so it'll be pretty simple. What I'll do is I'll start at, I guess 6.5 will be right here. And then we can go all the way up by 0.1. Now I have a purple marker. Since the west was 7.2, I'm going to come on up here to 7.2, where that's at, make my little line here, and then make a bar. That's why we call it a bar graph, because it has bars. And then I'm just going to color it in. Now, if I had more time, I would probably color it in a little nicer, but I think this is fine on its own. What do you think? Next, I'm going to do East Oklahoma. East Oklahoma was at 7.0, so I'm going to go 7.0 and go across. I'm going to make my line there, and I'm going to draw my bar. And again, I'm coloring it. That way we can see it. Yellow might not have been the best color for this, but it'll work just fine, I guess. And then finally, tap water was at 7.6. So I'm going to go all the way up here to 7.6, make my line, and come all the way down. And then I'm going to color it. Now clearly, when we get done coloring, you will see that the highest pH level was tap water because the bar went up the highest to 7.6. The lowest pH level was the eastern Oklahoma water with 7.0. And right in the middle was western Oklahoma with 7.2. And that is how you make a bar graph.
So the question that was posed to us is, why is the pH different in West Oklahoma and East Oklahoma? But as we've learned, there's actually a few reasons it could be. One of the reasons is actually the decomposition of plants and organic material. If water has a lot of organic material in it, and once it dies, that turns into carbon, and the carbon mixes with the water, which makes it an acidic.
Absolutely. And you know, another reason that soil pHs can change may be the bedrock or just the composition of the soil itself. Limestone can actually act as a neutralizer or neutralize the pH.
That's interesting. Another big reason, human reason, dumping of chemicals. Chemicals have a strong effect on the pH level. Even the simplest stuff, such as shampoo, can directly affect the pH level of water.
You know, and humans can also interfere with the pH cycle just by driving cars and pollution that causes acid rain and these gas clouds build up. It rains this acid and it changes the pH level of all the waters in the state.
True, so true. But you know what? We did our research.
And we did the trip.
That's right. And guess what we know?
We know the pH!